Okay, Lan, we are there. When you want, we can start sharing the slides and start the session.
Yes. So I will kick off the afternoon session. So good afternoon to everyone who are present in Tavis and who are connecting like me to the FOMI 2022. My name is Lan Yang. I'm a postdoc researcher at the National University of Ireland, Galway. Or I should say the University of Galway, because our university was renamed officially from September. And I hope to say welcome to all of you to this hybrid session on domain ontology harmonization for industry. So first, may I thank each of the speakers and panelists for taking part in this event. I also want to thank my colleagues Izaskun and Mirko, who are in the room with you and can help me handle the things that I couldn't do remotely. We also have Patricia and Sylvia, who kindly agreed to help taking notes for the presentation and questions. And finally, I want to thank and welcome all of the audience again for physically or remotely joining this afternoon session. So in this session, we will have 3 presentations and 1 panel discussion. I will introduce each speaker briefly, and they will give presentations, and then we will have a 5 to 10 minutes Q&A session at the end of each presentation. And then Izaskun will host the panel discussion in the room, and she will introduce our outstanding panelists to you. So our first presentation will be jointly presented by Dr. Emilio Sanfilippo and Dr. Arko Saka. You have met them both yesterday and today, but I will spend 30 seconds to quickly introduce them again. So Dr. Sanfilippo is a researcher at the Laboratory for Applied Ontology at Institute of Cognitive Sciences and Technologies in Italy. And Dr. Arko Saka is a postdoc researcher at the National School of Engineers of Tavis. So Emilio Arco, the stage is yours. You can start your sharing your slides and start your presentation.
Okay, thank you, Lan. So I will go first and then...
Emilio next. Okay, perfect.
Okay. So I don't know if you can see the room. It's pretty full here, just to let you know. Okay, so let me share the... Okay, excellent. Okay, so in our project Onto Commons, right now we are involved in a particular task, what we call domain ontology harmonization, and then and it is part of what we call the work package 3, which is mainly for this harmonization task, but then there were other tasks also in this work package. Before this effort started was to gather requirement and then find the existing ontologies which are there for the industry and then material science and etc. Now here we want to present what we found in the focus group of manufacturing. So of course there are other focus areas in our effort. We kind of like group them for sake of, good management and organization. So there are products and services, there are of course supply chain, there are other topic, also material science. But in this presentation, we are mainly focusing on manufacturing. So I will first go through some of the results we found from our requirement analysis. As you have heard from the keynote of Elisa, that first defining the requirement is extremely important before you can develop the ontology. But and just to point out that Onto Commons goal is not to develop new ontologies. Of course, if needed for some area we do not find existing ontology, we will develop new ontology. But then the primary goal is to see how we can harmonize the existing ontologies. So when we started this requirement engineering, we first needed to find a good methodology for that, and we somehow adopted the LOT methodology, if you are aware of that, proposed by Maria Poveda from UPM mainly. But we also needed to adjust it a little bit for the purpose of Ontocommons, because first of all, it's a very big project. We are not trying to focus on only one focus area. We have very different, different areas of focus. But we try to keep it as, at the high level, it is very much similar to the LOT. So what we say that, okay, we need to find some use cases and then gather requirement from the use cases. And of course, Ontocommons has 11 industrial partners. If you have seen in the keynote of Hedy, and then you can also go to the ontocommons.eu website to find the names of the industrial partner. However, right now there are 22 industrial partners, but we will do another round of requirement analysis later, which will be as part of our second version of the report. But in this first version, we only considered 11 of them. So they, of course, supplied us with use cases, user stories, and requirement. But then, of course, if you are talking about one particular topic, say manufacturing, they are kind of split into different use cases, different user stories. So we needed to then collect them under one set of requirement, which will be the domain requirement for manufacturing. But we collected the requirement from the use cases, but then we found that when we compile them and then also clean them up a little bit, they still need to be extended to cover the areas of manufacturing fully. So what we did, that we went to the experts in this area, both internal to Ontocommons, who are member of Ontocommons, but also external expert. And then we had a few focus group meetings with them, and then we collected the requirement. So in the end, we actually divided them as non-functional and functional requirement. So what we call functional requirement are which are purely stated as a competency questions, whereas non-functional requirement is what we collected as an opinion or some best practices or something in the field of manufacturing, which came from the experts. Now, of course, the scope, I already talked about it is actually switched. So the first one is the purpose. So the purpose is to cover, is to compile and align existing ontologies, as I say, capturing the taxonomies of manufacturing process, resource, planning, and control mainly. And then establish this domain level ontologies, kind of align them to the mid-level and top-level ontology. But what we call is what we call an Ontocommons ecosystem. So we actually have a mapped version of the top-level ontology we call top reference ontology, and similarly we have a mapped version of the mid-level ontology we call MRO. So it is to somehow link them, these domain ontologies, to MRO and TRO. And in the scope, we of course have for the topic planning, scheduling, controlling of process, resources, factory, shop. But for the industry, the use cases come from all sort of industries. So there are automotive, aerospace, energy, chemical, food, apparel, agriculture, you name them. So some result from the first, from non-functional, is that first is that, okay, experts heavily mention these standards, which are very old, but then extremely popular: ISA 95, enterprise control integration, ISA 88, batch process control. Of course, then it was mentioned that we should look into these languages, which are mainly used for system modeling, system designing. So OML, SysML, ISTIDL, of course, Modelica, and then Cameo, and then all of these system modeling tools were mentioned, who uses some form of this language, but also has their proprietary version, which are kind of extension of them. Where the ontology of manufacturing will be used to, first, of course, to exchange information, knowledge between different industrial sectors, nothing to talk about that much. But some interesting point is that that ontology can help in actually do some trade-off analysis between the alternative design and planning. So if you have alternative system design, and then ontology may help in analyzing them, because they are coming from different sources. So you need to actually compare them, you need some standard vocabulary. But then also to translate the model from, and this is becoming hugely popular, and ontology may help. So if you have a Cameo model, maybe you want to do some simulation on top of that or you want to transport the model from one language to another, one tool to another tool. And of course, characterize processes, including their capability. So process capability is a big notion in the industry, but surely it's ontological. It's a capability of the resources involved in those processes, but also control, how to control them. And okay, if we can characterize the process, it will help in doing some analysis of historical process. So it's kind of will help in process mining as of it is, as it is known. So coming to non-functional requirement, it is said by the experts that when designing the ontology, we need to consider the perspective of the human being involved in the manufacturing process. So who are human being? Of course, like this controller, planner, designer, managers, workers in the manufacturing. So it was a nice statement. I kind of captured it. They said that manufacturing should be seen as an intentional transformation of a physical entity to achieve something. So you can see the point, intentional. So it is highly from the perspective of the human being involved in there. And then we have to take care of the difference between the discrete manufacturing and the continuous manufacturing, because the terminologies are very different from discrete to batch. And then system behavior is very important. Ontologically, the behavior is not very much modeled. I know that Francesco talked about behavior a little bit in the function modeling, but the user of the ontology wants to see actually the SysML state diagram and then UML state diagram kind of translated into ontology, as you can understand. Also, alternative control policy, alternative design, this needs to be captured in the ontology. Performance indicator is another point. We found that they want the performance indicator to be represented because they want to really see the measurement of their system. And then, of course, it is of course known that same terms may have different concept, and the same concept may have different terms from one industry to another. Now, we collected almost 144 competency questions. 144 competency questions for the manufacturing. I cannot show those questions like that, but we kind of did a very high level analysis, and then I can present it in this way. That, of course, if we see all the competency questions, we can actually separate them into three types of group. One is, of course, talking about the physical entities. So resource, asset, machine, tool, factory, and then storage system, but also the consumables, like say raw materials or anything you need for the process, for the manufacturing. All are physical entity, and there are a lot of competency questions on them. Then, of course, the process. And the process, of course, in terms of only process, but then, of course, the behavior, as I said, then they want to also represent the state event, and then for planning and control, they want to do the routing. They want to represent the routing, different routing of the say. So all of them kind of come under the process, and then there is something, everything what I said about the human exchange. In the manufacturing, say for example, the plan, objective, and then requirement, the goal, and then also the capability, and then function. If we can say that, okay, these are all intentional entity, kind of separate from the process and then object, but then they are extremely important in terms of management, because the experts or the people involved in there talk in those languages. However, they are very much subjective, and it's highly debatable how we can model them in ontology. So the ontological position is, kind of tenuous. And then all of these terms are used in the middle, we say that, okay, so the designing, planning, scheduling, controlling, testing are of course processes, but these are the operations where these terms are used in the manufacturing. Then there are some kind of social entities they are also interested, which help them to exchange this like ideas. Say for example, different model, system model, can be numerical, can be visual, say CAD model, can be geometrical, conceptual. System diagrams for sure, like functional block diagram, parametric diagram, and then activity diagram, all sort of SysML diagram you can think of. Then of course, then comes at the business side, you have all sort of documents like sales order, purchase order. So these orders, of course, if you think an ontology, maybe these orders do not have that much importance, because these are just a traditional way, a legacy way to represent it, to capture some information, to print it, to show it to the other stakeholders, something like that. But then experts say that we need to model these things. So this is all about this, and then I will just give it to Emilio. Just one thing is that we will go for the harmonization, but then just for this harmonization, we collected some existing ontologies. So you can see 3 of them here, and then on the next we have some of them, and then yes, Emilio.
Okay, thank you. So good afternoon. I will now step in a more, let's say, theoretical work, which is related to the project, but also to research work that we did at the laboratory for applied ontology. And the general context is the things that we have been already discussing in these days. So the fact that when working in engineering, but not only in engineering, we have multiple interpretations for the same terms. And so we need to find a way to compare this multiple interpretation to understand what we want to do really then with all these materials, being them standards, ontologies, or other materials with which we work. So, for instance, if we consider this definition of manufacturing resources that you find in the literatures, on the one hand, for instance, you have this definition saying that a resource, it's any device, tool, or means, except raw materials and final product components at the disposal of the enterprise to produce goods and services. On the other end, the second one says that a manufacturing resource is a business object, such as people, material, information, and products used or produced by business systems. So already, from a very general point of view, you can easily see that on one hand, they have materials, while on the other hand, they exclude materials. And then the same thing for products, right? Here, they count product as resources, while in this case, they do not count them as resources. So if you want, in the first definition, resources are really understood as mechanism, which you use to manipulate, let's say, the thing that you are doing in your enterprise. While on the other end, these are both mechanisms, but also the input and the output things that you use to manipulate, to execute the manufacturing process. So then what happens? If you develop an information system, a software application, based on this kind of definition, I mean, on the model which are behind this definition, then you really run the risk of having interoperability issues. And so what can you do there, I mean, from an ontological point of view? So in the study that we proposed and we presented in some publication, and especially this one, which was published, I think, last year in the Journal of Applied Ontology, with colleagues at CNR, Stefan and Walter, we compare various perspectives in formal terms by using first-order logic. We adopted a descriptive approach. So we discussed the advantages and disadvantages of different points of view. And then we try to propose a unifying perspective, which consider the benefits, let's say, and the disadvantages of each view. Okay, so to be very quick, I can skip these slides. I mean, the first view which we found in the literatures is where resources are understood with respect to events, so things occurring in time. So there a resource, it's really the object that you use. Okay, it can be a material, it can be a screwdriver, it can be a machine. It's something that really you use in the system. Of course, I mean, this kind of view, I mean, cannot represent manufacturing resource at the planning level or the scheduling level, where you really have to take into account more the description, but not the physical things happening in the world, right? I mean, you are in a planning scenario, you do not have the occurrences in the world. In this case, you cannot consider things as resources. Then the second view documented in the literatures is where indeed, I mean, resources are now attached to manufacturing plants. Okay, we call them activity in the paper because we took the terminology of the process specification language, where they call plants activities. So this is suitable for planning a scheduled scenario, so where you do not have the physical occurrences in the world. On the other hand, I mean, it requires the existence of plant specification, right? Well, there are some modeling scenario in engineering where people even abstract from the plan. And so the third view, which is also documented in the literatures, relates resources to goals, okay? So, I mean, at this level, you are very general, or better said, you are very abstract in the sense that you do not have a physical occurrence in the world of an event. You do not have a plan specification, but you as a person working in industry have a goal, right? And you say, okay, this is the resource which I want to use for my goal. So for the findings, let's say, of this work, well, the first thing that we say is that we didn't find a golden approach. We actually think that there is no golden approach among these three points of view. It's not that one is better than the other. It's just that one suits maybe better than the other with respect to an application setting, to a context where you find yourself, right? So in the first case, because you have the link between physical items and things happening in time, this can be really good, for instance, for manufacturing execution. The second view links resources to plants, so it fits very well for the data system design and production planning, among other application contexts. While the third view links, as I say, the resources to goal. And so from an engineering point of view, it can be really useful in the heavy system design, where you are really at the conceptual level specifying what should be, but you do not have yet the all set up. So again, I mean, it depends on where your, let's say, conceptualization, your application is, then you can select one or the other view. Still, I mean, if you just rely on one or the other, you might have interoperability issue if you then wish to share the data from one view to the other view. So in the proposal that we did, no, actually there is this first slide before, sorry. So another finding, okay, is that it emerged quite clearly from the literatures that resources are represented or are conceived, let's say, as role. So the role that an entity play in a certain context. So if you take, let's say, a screwdriver, okay, as Stefano was saying this morning during his talk, I mean, you cannot count necessarily it as a resource functional to a certain task. I mean, it becomes a resource when you do certain things, or when you use it for a specific purpose. And this role view, I mean, it's quite documented in the literature, and that's it. This is also a finding, let's say, of the analysis. Okay, so coming back now to what I was saying before is that anyway, if you stick on one view or the other view, you might have still interoperability issue to move from one to the other one. So the proposal that we made in the paper is that of unifying these three views in order to allow a smooth integration, let's say, of the data coming from one to the other. I mean, we did this at let's say, at the modeling level. So we haven't tested, let's say, the interoperability between the three views by means of our work. But we are still working on this, especially from a more application side. Actually, the presentation that we did yesterday at FOMI workshop is also related to this work, where we put, I mean, the theory into a practical system for engineering. And in this case, I mean, in the proposal that we specified, I mean, the manufacturing resource is indeed the role played by an entity which satisfies a certain requirement in the context of a manufacturing plan. I agree with you that this is maybe still vague as a definition, and it's something that has to be further refined with respect to more specific engineering knowledge and details. Okay, so now coming back to Onto Commons, maybe Harko, do you want to conclude with a brief concept?
Yes, I can. Yes. So as I was saying that there are some existing ontologies which are which we kind of enlisted, but then now from those competency questions, so we need to filter out the important terms. As I showed, like the terms, we started to group them and then analyze them, and then kind of see which terms are similar to each other. But then, of course, at some point of time, we have to find some list of terms which are the most important, or the important is not the right word, the most general one, which we need to first attack. Those terms are, we will also see that if those terms are in those existing ontologies, in any of those existing ontologies, so that means that if we can somehow have those terms defined properly, then we can map those terms with the existing ontology terms. So in that way, we are kind of trying to harmonize the existing domain ontologies. So, so to start making those terms, first of all, more understandable, or like define them properly with more elucidation, I will say. We have created a template called breach concept template. So those terms, we are calling them breach concept, because it is not that we are trying to define those terms as a new ontological entity. We are considering those terms that they are repeated in the existing ontologies. So this term needs to be mapped to map those existing, to align those existing ontologies. Now, say for example, one term is called resource. So the resource term, then we need to first see that what are the existing ontologies, how they are defining this term called resource. So we are compiling those information, those natural language description and definition, and there is a template we are following to do that, so that it is kind of same for all the terms. The template is available in the GitHub, but if you go to the Onto Commons Ontology Framework, is the GitHub, is the repository name, you will find the template there. And also you will find that the same template used for many different breach terms, what we call it. I mean, there are resource, product, and then process, and then other things. Slowly, it will increase. So of course, we want that the experts, some of you are already involved, I know that, but then we want more involvement from all of you, and then you can choose, of course, we are talking about manufacturing here, but of course, there are other focus groups, so you can choose your focus group and then join the discussion.
Okay, thank you.
And then about those terms, we will talk a little bit more on the fourth day. There is a session called OCS.
So I hope that you can see that, I mean, what I just discussed before, I mean, it is functional to this exercise, in the sense of defining a notion which can play this role in the context of the project. So that's all from our side. Thank you.
Thank you very much, Arco and Emilio. I think I will ask if there are any questions coming from the audience in the room first, and then I have one question from. I have one question online.
Yeah, there is a question from Lucian, I saw. Yeah. Should I read it?
So the question is, what is being unified in your approach?
Yeah, so I mean, as I discussed, I mean, we found this strict interpretation of what is a resource with respect to plans, events, and goals. And then the idea is that unifying the understanding of resources among, let's say, these three contexts. I don't know whether this is clear, or you can comment if you want in the chat. There is a question from Chris. Do you want to come closer to the...
Can I try without? Because I think I have to I feel put on the spot. I noticed you talked about the software applications, the stuff that you did, which I think is good. But I just wondered, I know it's the same question I asked Elisa, whether you had test data. So in other words, whether you could look in the application systems and see the data structured in a way, because the documentation, if you work in the commercial field, the documentation typically has absolutely no relation to the system. I mean, it's done by junior people after the system is done and they've never worked with the system. Maybe
Right.
I'm being unfair, but that's my experience. So I'm wondering how you can verify the
Right.
structures that you do. I mean, I thought it was a really nice analysis and it was that's good, but I just wonder how you verify it against the data.
Yeah, I mean, we discussed this a little bit yesterday with respect to the application to the data. I mean, what we are doing is that there is a colleague of ours who is co-author of the paper, who is a mechanical industrial engineer. And I mean, we do case studies based on production planning, essentially, right? And so they collect data, and then they model the data with respect to the ontology, so that the way in which the data are produced is compliant with the ontology from the very first steps.
Did you find a commercial system?
Oh, well, no, at the moment, I mean, this is done more at the research level.
Can I also add some?
Yes, sure.
Yeah, so about the Ontocommons, as I showed those requirements, I mean, your question is very much applicable that, yeah, what is the data for all of those use cases? And then we are trying to, I mean, talk to all of those, our industrial partners who actually supplied those use cases. And so it's not, I mean, it's not completely a pretty picture there because some of the data, proprietary data, they are not ready to share. However, some has promised that, okay, they will share the data. And then, so that will be, I mean, whatever data we can get in that way, you are absolutely right, that will be, I mean, very much necessary for
That's
testing.
a really good thing, I think. When I saw that on the project, I mean, that's a good sign of a healthy, connected grounded project that you have. That was really good. I thought this morning when you came through that was a good sign.
Yes, I hope those data will come. Yeah, yes, I mean, I have some promises, but then, yeah, it takes a lot of time to release the data and then.
It's really difficult to get all the data.
Yes.
Is there any other question?
Do we answer?
Yeah. Okay, I think that's from the audience. It's all.
So then I may use 1 minute to test the microphone with Professor Barry Smith. Hello, Barry. Can you hear me?
I can hear you. Can you hear me?
Yes, perfect. Yes. Then so I will introduce our next speaker.
Can you just let me share my slides?
Yes, please.
Okay, that worked, I think.
I can see the presentation mode. I don't see it
Good.
in the presentation mode yet, but I can see your screen.
Great.
Yes, perfect. Now it's in presentation mode.
Good.
So I will just give a very brief introduction and then you can start, Barry. Thanks very much. Well, Professor Barry Smith is the founder of National Center for Ontological Research at University of Buffalo, United States. And he is also a founding coordinator of the OBO Foundry, and he contributes to many biological and biomedical ontologies, and he has been centrally involved in the IOF initiative as well. So Barry, so when you are ready, you can start your presentation.
Thank you. So the IOF will be dealt with in a series of sessions all of its own tomorrow. I'm just going to provide an introduction here, how the IOF came into existence, and show you examples of the content that we've created. As I think many of you know, the basic formal ontology started in connection with the results of the Human Genome Project. These results were in the form of long and complicated genome sequences, which didn't make any sense to a biologist or a clinical researcher. And the gene ontology, which is still by far the most successful ontology in many respects, was created as a vehicle to tag genomic sequence data with terms derived from ordinary biology and medicine. And in order to extend the range of the gene ontology, we created a series of other biomedical ontologies, which were put together to form the Foundry. And the idea behind the Foundry was that all of the ontologies developed within it would be developed in coordination with the developers of the other ontologies within it, so that we have from the very beginning an interoperable collection of ontologies. And this is where you find all the ontologies now, and the various software and other features of the ontologies which are being continuously tested. And this is the structure. So we have a top-level hub, and then we have domain-specific spokes at various lower levels. And all of the domain ontologies thereby can be seen as having this as their starting point, the terms in the top level. And the top level is designed to be a rather small and very generic ontology. And BFO is one top level ontology. Dolce is another top level ontology. So this is the picture as it looks, with BFO at the top, the ontology for biomedical investigations in the middle, and then all of the various domain-specific biomedical ontologies and the bottom block. This is BFO 2020, which is the latest version of BFO, which was created in connection with the ISO standards process, which I'll talk about in a minute. And these are the material entity terms in BFO. These are the attribute terms in BFO. These are the process terms in BFO. And these are the information entity terms in BFO. So you can see that BFO is very small. It's designed to be small so that it can be easily taught and easily applied by many, many people in the same way. That's the goal. It's been maintained over now 16 years by a group of people who are all of them very argumentative. And so we think we've argued through at least the majority of the potential problems which the definitions of these terms might involve. And this has worked. So the OBO Foundry is now not the only foundry using BFO. There are many others. Some of them quite big and quite influential in their different domains. And the one I'm going to talk about today is the Industrial Ontologies Foundry, which was started in 2016. We are now just about ready to release the first suite of ontologies within the IOF. and I'm going to talk about the core IOF ontology. But first, I need to say a little bit more about the Common Core Ontology Suite, which you see at the top here. This was created on the basis of an IARPA grant in the US to solve problems of data analysis in a very rapid way, where the data could come from one of many unanticipated domains. And the problem was to create software which could interpret that data very quickly without knowing in advance what the data was about. And the Common Core Ontologies is the basis of a project which was one of the winners of the challenge grant that was awarded for this. And it was the only winner which had an ontology approach. And the idea is that these high level but not top level ontologies cover very general areas where you find different kinds of types of entity. All right, now that Common Core ontology work was sufficiently successful that it led to the ISO standards organization conceiving the idea of making BFO an international standard. And this came about. The standard currently is in two parts. Both of these parts have been approved. You can get them online. You can even get them free online if you press the right button. And the first part is a statement of requirements for being a top-level ontology. And these have to be requirements which can be verified. In other words, you can verify that an ontology satisfies the requirement. And I invite you to look at them. They are, I think, quite illuminating, because the challenge was to specify a verifiable requirement for being an ontology which is such that it could apply to every entity in the universe. And then part two is BFO, which basically shows that that the BFO 2020 satisfies the requirements set forth in part one. And that there will almost certainly be further parts. So Dolce and Tupper are two ontology efforts which are being considered at the moment for being parts 3 and 4 in this set of standards. So there are something like 500 domain ontologies extending BFO, and you can find the list there. Most of them are biology and medicine, but we have increasingly large numbers in relation to the other suites described earlier. But now we'll talk a little bit about the IOF. So this is the general strategy. So we have the IOF core, which I will conclude with in a minute, and then we have some working groups which have ontologies which are based on the IOF core and which are already in a mature state, and these are the yellow boxes here. And then we have various materials ontology efforts which are also in a mature state, but they do not form a harmonious whole because they were developed independently, and there are overlapped problems. And there are other materials ontologies which we intend to use, including the EMMO ontology, where we hope to be able to find a way of using some of their content in such a way that it is compatible ontologically with the IOF core and then with BFO. Now, the problem with materials ontology is that the term material and materials terms like sugar or metal or water are used in two quite different senses. In one sense, they are referring to types of substance, and in another sense, they're referring to portions of material, for instance, material which has been shaped to be a wheel or a gear. And the problem is that developers of materials ontologies in the past have very often confused these two uses of the word, which are very different in all kinds of ways, and which both have instances and universals on their respective sides of the definitional picture. Okay, now quickly back to BFO 2020. These are the material entity terms. These are the material entity terms in the IOF core, which look like this. So we have material artifacts, assemblies, machines, we have agents, we have systems, we have maintainable items, material components, raw material, and so on. These are the attribute terms in BFO, which means qualities, roles, dispositions, and functions. And these are where they appear in the IOF core. And these are the qualities, roles, disposition, functions. And we are now adding capability into the picture. And so you see function and capability over there on the right, agent role, and so forth. So, and then we move to process terms. These are the process relevant terms in BFO, and these are the occurrent parts of the IOF core. And so we have planned process, computing process, measurement process, manufacturing process, assembly process, and so on. And there you can see that in a slightly larger font. And I believe, well, no, I'm not quite done. So now we see information entity. These are the information entity types used in the IOF core. So designs, directives, designations, location, identifications, and so on. And that is where oh no, I don't stop here. I wanted to mention, and I don't normally do this, but the book just appeared, and so it's very much uppermost in my mind. So we all want to make AI work to help us do our job in using ontologies to help people, for instance, in the manufacturing world. And AI really will work, but mostly it won't work. Most of the claims people make on behalf of AI, or let's say most of the more ambitious claims people make on behalf of AI, will not work. That's what this book is about. But the final chapter is about just the sorts of things that we're discussing here, namely how AI will work in areas like industrial manufacturing. And so now that really is the end. Thank you very much.
Thank you very much, Barry. That's a very interesting talk. I don't see any questions posted from the platform, but I wonder if there are anybody in the room wants to ask questions. And can I remind you to pass the microphone to the audience, because we can't really hear if someone speak without a microphone. And I see PC2 is muted as well. Perhaps we need to unmute the PC2 as well.
Sure. And if anyone has a question,
Anybody wants to ask questions?
It's better to approach. I apologize for the inconvenience.
Because we have only this microphone, right?
Oh,
I can't take that and go. It's what I can.
I forgot.
Yeah.
I forgot. It's my fault. If anyone? Oh, thank you.
So if any of you want to hear more about the IOF, then there will be lots of opportunities tomorrow.
Tomorrow as well. Yes.
Yeah.
I'm going to mention that as well.
I would have a question. That's Stefan Brünner from Siemens.
Could you repeat the question?
I'll write it down.
Yeah. Sorry, you're muted again.
No, try it again. I was configuring.
Is the microphone working? Can you hear me?
Yes, perfect.
Okay, that's Stefan from Siemens. I'm having a question concerning what you just presented about the IOF core in combination with standards and industrial standards. So my question is, how are industrial standards supposed to be used together with these models? As an example, I could take the ISO 95 standard, who speaks about things like manufacturing planning and manufacturing equipment and these kind of things. And I've seen domain or cross-domain models in that picture that are exactly about that. So is the idea that we build ontologies for these standards that derive from these IOF core models, or how can I imagine that to work from my take?
Yeah, so that's a very good question. We were working very hard through the whole course of development of these ontologies to ensure that they were based upon the best statements of not only standards organizations, but also glossaries and so forth produced by industry from various sources. Now, the problem, of course, is that the ISO standards methodology does not require coordinated evolution of standards. So the standards are developed not in tandem with each other, but separately. The second problem is that ISO doesn't place the right sorts of restrictions on definitions. So the definitions in ISO documents are definitions based on dictionary standards, not on semantic or logical standards. And so there was no way we could just import definitions from standard documents, which is what we would have liked to do. Because that would have led to a logically inconsistent set of definitions. But we did work hard to make sure that our definitions were, as far as humanly possible, consistent with the expectations that people would have who are using those standards.
Okay, thank you.
Do we have any other questions from the audience in the room? If not, I will proceed with our next speaker. Thank you very much, Barry. So I would like to welcome our next speaker on the stage. I don't see him as speaker at this moment, but I can see him in our session. Could you put him on the stage? Hi, Noel.
Hi.
Good to see you.
You can hear me, right? All well.
Yeah, I can hear you just a little bit low, but I can hear you.
Oh, okay. I'll put the mic here.
Yes, perfect. Could you try sharing your screen with us?
Yes. The button doesn't seem to
Enabled?
enable. Yeah, it's disabled.
Could you enable the share screen function for Noel, please? I think we have to ask the host to do that. I don't have the function
okay.
either. Or I think the screen is occupied now. That's why you couldn't share. It's disabled for me as well at this moment. So now you can do that.
Okay, now I can do it. Yeah.
Yeah.
Share screen. Yes, share screen. Okay, so you can see. I'll put.
Yes, now
Yes,
I can see.
right.
But there is like a delay. Yeah, now I can see. Yeah.
Yeah,
So
if
I'll
I.
be,
I might need to switch tabs, yeah.
Yes, I can see that. Okay, so let me introduce to the audience our last speaker, Dr. No Vizcaíno. I hope my pronunciation is correct.
Perfect.
So Dr. Vizcaíno is a research software engineer at the Scientific Computing Department of Science and Technology Facilities Council of the UK. And he advocates for the use of international standards and the adoption of practices from the software engineering body of knowledge. So now you can start your presentation. The stage is yours.
Well, thing is that I know that it's 10 minutes, so let's see how I manage to cram and not to lose the audience. Like the title says, like the influence and the widespread adoption of JSON-LD based international standards. What happens is that JSON-LD is a foundational standard. So there are other standards being written using JSON-LD standard, right? So that's going to have a massive impact. So it's like JSON-LD and the ecosystem, right? So moving on. What happens with the standards is that whether they're de jure or de facto, they set the stage, right? And they become prerequisites for any development to happen. And they have a lot of staying power. Just look at Dublin Core. Dublin Core is quite old, and ISO that's a geospatial standard, the ISO 19115, and they bring knowledge and structure to the current environment we are working with, right? Because sometimes like people don't know where to start, or right, or there's a software development, and you need some pointers, right? So standards is not a bad place to start. And there's massive amounts of cross-pollinated compliant data, like standards use another standards, and you end up with a web of standards that they feed on each other, right? So that you cannot ignore. So what happens with metadata serialization? Like XML was a pretty significant standard, still strong, but because of APIs and because of its simplicity and it's easy to load let's say a web client, right? Loading JSON is kind of like for exchange as a payload, is relatively straightforward. So it ended up replacing XML, and that's a downgrade in disguise, in my opinion. And that broad adoption is not a good situation, right? But something happened, and what happened was that this standard came about. And just for those who are not familiar with it, it's an RDF document that is a superset of JSON, and that's compatible. Major search engines like Google, Yandex, Bing, Yahoo, I think all of them support it as web metadata. And they came with a vocabulary called schema.org, but DCAT is also accepted. So mainly for data sets, but schema.org is fairly general. And also the Google Knowledge Graph emerges thanks to that, right? And the key thing is that any JSON with a JSON-LD context also becomes semantic linked data. So that's the important change. And it favors modularity and extension by addition. So that's a really good point. And I think it's the most advanced RDF serialization yet. Well, of course, I put the note that only YAML LD star comes, but still, it will stay with us for a while. You'll understand why in a second. And the underlying, let's say, paradigm is a graph, which is, yes, it's a schema, but it's really flexible compared to anything that was before, right? And it's perfectly suited for metadata. So a state-of-the-art metadata is done with JSON-LD these days. So why I'm insisting on this? Because it's not just the standard, it's that it's been adopted everywhere. Used in W3C in many standards as a default serialization. Most standards are fair by design, of course. So you have Google datasets, you have knowledge graph. The whole USA administration has a standard based on it, which is DCAT US. The CERN Open Data Portal uses JSON-LD and schema.org. Bloomberg Professional Services for the Hypermedia API. The payload is going to be JSON-LD. Then in geospatial domain, you have like normal GeoJSON, which is just compatible with JSON. There was some conversion, let's say adaptation to GeoJSON-LD, just convert it to link data. But then a big body did another super advanced versions of it. So they kind of like expand in complexity, right? Then for the smart cities, there was a standard called NGSI, and Fireware and Etsy, which are the two big organizations, decided to create the link version of it. So it has high chances of being used everywhere. International data spaces, the data sovereignty program, which is a broker architecture, there's a standardization efforts, also uses this kind of metadata. Then in the question of mappings, that's an interesting point, that you have that geospatial standard, that ISO standard, DCAT, and schema.org, they are mappings for the different terms, right? But that's something to take into account, all these standards. Once they become widespread, the terminology will rule, right? And in life sciences, there was a huge success story with bioschemas. And I think I could go briefly for the people who are not familiar with. This is the standard. This is the latest recommendation, official one, as far as I know. And this is JSON-LD framing. That means that whatever is the JSON-LD sort of serialization could be reshaped according to what you think it should be validated, depending on some rules, right? And these are how the rules will be written. So briefly, I'll put a JSON-LD dataset from Google Datasets, the example. So this is how it looks like. So you have a context, and then you have a type. In this case, it's a dataset. You could have many types. That's actually recommended. And then you have a series of keys with data, and everything is specified. But this is a state-of-the-art metadata, right? And everything is going to look like this. The key of this is that this is not just what people think it is, because JSON-LD standard, if I copy and paste it in JSON-LD playground, you can do transformations and the metadata means exactly the same, but it's just expressed with different views, right? You can expand it, compact it, flatten, framed. You can have enquads, and you can visualize it. I mean, people can play a little bit with this, right? So it's not just the standard, it's just processing the rules is really, really big. Well, alternatively, Google has this to validate JSON-LD, and it might be a bit clearer to see what are the keys and what is the content and all these things. But there's no escaping this. And this is the standard, the DCAT US. And as you can see, all the keys are defined, and like this a long document. But all the US administration from federal level down to city councils, everybody's going to use this, right? And they have metrics for compliance. It's just really, really widespread. This is the basic JSON-LD, GeoJSON converted to GeoJSON-LD. And this is the Open Geospatial Consortium using that GeoJSON, making it even more advanced with more features, blah, 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 blah. So this is just Cambrian explosion of metadata. This is an example of bioschemas. And of course, this is a simple example, but bioschemas has a lot of specialization. There's a series of profiles for, let me just see if I can quickly find it. Profiles. If I click on profiles, let's see if we get it. Well, yeah, for computational workflow, chemical substance, gene, molecular entity, protein. So if you are in that kind of field, this is going to be a place to go to. And this will have strong consequences for harmonization, because all these standards is the data that is going to be out there, right? And this is for the smart cities. And there are many sensors, you name it. It's just super, super duper big. So it's like a lingua franca for metadata. There's an ecosystem. It's not just JSON-LD. There's an ecosystem. There's many aspects about it. Again, standardization or like the JSON-LD framing. And just to take a bit ahead of time, but there's a connection with software engineering. And we had a bit of a Copernican moment for practitioners, and things got inverted. We thought that the dependencies, hardcore dependencies like technologies, databases will be at the bottom. And this is the poster child example for the last 30, 40 years, which is like N-layer architecture, MVC, which is like you have a user interface layer and you have a business logic that access a data layer. And then at the very bottom, you have a database. But what happened is that things got inverted and they discovered that it's a lot more resilient to have it like this, to have a presentation layer, an application layer, and the domain, which is very important for ontologies, is at the bottom. That means that you are going to have dependencies on the domain. And for software engineering, that's just absolutely insane. And it's like, it's a discovery. Like you can spend decades doing something, it might not be the best way of doing it. So hard dependencies are now at the bottom. The core is at the center, that domain core, and any technologies on the outer rings. And the idea is that they could be easily replaced. But the communication between layers is the metadata that we need. This JSON-LD fits perfectly, and as is happening already because it's happening with web APIs. So from web APIs and widespread adoption is going to go also to software engineering. And ontologies are going to become a core part of software engineering, and particularly for scientific software development, of course. And they will drive complexity out of that domain core to make it easier to develop. They will become part of the functional product. Ontology standards will bring the terminology, so we don't need to, we can just go to the ontologies to see what's out there. They will affect the source code, they will affect the design, the modularity, the queries, the metadata, and the data. And of course, the users will also use the ontologies to interface with the system. So true interdisciplinary collaboration becomes essential. And I will say that Unix philosophy could be applied to ontology engineering. Like small ontologies that are very minimalistic and concise have higher chances, I think, to make it big, right? Rather than trying to make an ontology that is going to cover a lot of cases. And as I said, like for me, JSON-LE is the perfect metadata today. And another advantage is that you can straight import it in graph databases. So, and and there's a lot of use cases for it already. So we end up with a really good situation that this kind of NoSQL database are also supported. And of course, ontologies fall squarely into that. So like a universal serialization. And I will say that there's this ISO graph query standard being developed as we speak by the same committee that did SQL. So in a few years, we could have a massive standard for graph querying. And that goes beyond what Sparkle can do today, or Apache Gremlin, which is a way of procedurally querying graphs, right? That is also of widespread use. And JSON-LD is also REST and GraphQL friendly. But in the case of the latter, there are some overlaps. It could easily replace in some aspects, in my opinion. And any API should be simple and stable. That will be a good practice. So I just put here some links to remind myself to bring them in. But I think I'm going to wrap it like right here. Thank you.
Thank you very much, Noel. Thank you for this very, well, to me, it's a very technical presentation, but
I know.
thank you for sharing with us your experience with JSON-LD and its ecosystem. So like you said, the adoption of this W3C ecosystem can positively, well, has positively impact on the software engineering domain and can impact future ontology engineering as well.
Mhm.
So I have a lot of questions, but first of all, I would like to ask the audience to ask their questions. So I don't see any questions online, but I wonder if any audience in the room want to ask questions. I don't see the PC2 or PC1 on stage, but maybe I can ask my question first and then let the audience ask theirs later. So my question is very simple. So in your opinion, how can this JSON-LD help the foundation of newer standards in ontology development?
Well, the thing is that there are lots of features. The fact that it's so advanced, it has more features than what people will normally expect from RDF. So I think that I will say one of them will be like how easy is to compose things, how easy is to make things semantic. And you have facilities like you can do aliasing, you can have different contexts for different situations. I mean, it will be really, really long to explain everything. And just inviting people, check it out. And beside that, I will say that just because one thing is the standard and another thing is the adoption. So once you have a lot of data and becomes big data, then that's the data you have to going to take into account in your harmonization efforts, in the terminology choices, alignments, you name it. You won't be able to ignore it either. And if you do any AI on data, well, that's the data you're going to have to do like machine learning, let's say. So, yeah, the thing is that I'm not sure how familiar people are with it so far.
Yeah.
I have,
yeah, but like you said, the first step is check it out. Yeah.
Yeah, but I strongly advise people to check it out, and you won't be disappointed. Of course, it's a compromise. Something better could come later, but I think it's important to. Because I think that the ontology work from a software engineering perspective, we need them to be ready so we can use them. So people are going to use whatever is already standardized by a legit, let's say, body. Of course, a research ontology is harder to convince people to use, but big standards, they have a better chance, right? Or maybe a de facto standard emerges. That also happens very frequently.
Yeah, de facto standards emerges. Yeah. So thank you very much, Noel. I think we should go along with the next event in the agenda, which is the panel discussion. And I think I will use this time to welcome all the panelists on stage. And perhaps Izaskun, you can tell me what's happening in the room. We don't see anybody now, just me and Noel on the stage. So just wondering what's happening in the in Tarbis. Thanks very much, Noel.
Thank you.
And our panel discussion, I think, will start from 3:15. So we have 3 minutes to get everything prepared, and then we can start the panel discussion on time.
Okay, yeah.
Hello, can you hear me?
Yes.
Okay, so we tried here to get some question from the audience, but we did fail for quite some minutes. But if it's not too late, I can. Well, I'm not sure if it's too late now to ask a question.
I see Noel is still with us. So if you want to.
Okay, I'm hearing.
Where's the camera?
But you have to use the microphone, otherwise we can't hear anything.
Okay.
Anyone in the room has questions for Noel before we start the panel discussion? This is your last chance.
Switch the microphone. Or when you switch the camera.
Yeah, I think there are too many things happening at the same time.
Yeah, on the side.
But yeah, but I encourage everyone who has questions can leave the question in the chat as well, and then Noel, you can check it out later. Yeah, I can see our panelists are on the stage. Hello, everyone. I can see all the panelists just except for our host, Isas. Oh, hello, Isaskun. I can see you now. Yeah, so I will hand it over to you and we can start the panel discussion in 1 minute.
Yes.
Thank you.
Take 1 minute.
1 minute?
She said.
Microphone. Hello. Hello.
Do you think that we need it?
Yeah, it's a big room.
Okay. Blanca said we need 1 minute. I don't know exactly the.
She said like to prepare, I mean to let us prepare.
Okay, we start with that. Okay. So, thank you so much for being here and for attending to this panel. Let me briefly present the panelists, but although I think that most of you know them, but on the first side there is Chris Patrick, which is the Chief Ontological at Boros Solutions. And he has been working on the pragmatic application of ontologies to information systems since last some years. The next one is Marcus Stamper, Industrial AI Research Center at the University of South Australia. He also leads digital technologies and interoperable in the future energy exports. And he's the member of ISO Technical Committee for Oil and Gas Interoperability. Alejandro Salado is from the Department of System and Industrial Engineering at the University of Arizona. He conducts research in problem formulation, design of verification and validation strategies, model-based system engineering and engineering education. And the last one, Dr. William Sobel is okay, sorry.
Take it.
He is the chief architect of MT Connect Institute and chair of the Industrial Ontologies Foundry of MT Connect Working Group. He offered the MT Connect standard to facilitate the machine tool connectivity and analytics. So, okay, you have been present in these last days, and we have that where we have been talking about different ontologies, the use, the relation with the standards, and so on. And David Leal have shown that in some specific domains there are many standards and potential domain ontologies developed based on them. We have some potential benefits in the industry when using these ontologies, but we are talking now here about harmonizing them. So we would like to hear your perspectives from different points of view about how this harmonization can help or can impact in the industry, going beyond the use of the ontologies itself. So maybe Chris, you can start.
Okay, so we can start. I have a problem in trying to work out what harmonization is in this case. I mean, if it is, if you talk about your top level harmonization, you have two ontologies and you harmonize them independently of the data, I think that's good to practice. I'm not sure quite where the benefits arise. And my experience is very particular. I work with operational systems and I start at the data level and I work at the data level. And I think the process of, well, there are probably two processes of harmonization. One is where the data presents two different pictures of the world, or maybe is vague about what it's saying, worlds and needs specification. And the harmonization process is a combination of trying to achieve consistency as well as more precision. but the consistency and the precision is driven by the operational systems. It's the precision and the consistency that they need to operate. So a standard situation will be a lift and shift. You might be going from a Maximo system to a SAP system, or vice versa. You want to lift all the data out, you want to clean it into Ontology, you want to put it into the other one. I think there is a process of cleansing, which you could call harmonization, and that's incredibly economically useful for the people who have the system, because the data in the old system has typically been used for a long time, and it could do with a spring clean. So I think at that level, it's a really good idea to do it. Maybe I should stop there. That's enough. Yeah.
All right. Okay. Well, I mean, leading on from where you stopped, I think harmonization to some degree is a euphemism, right? I mean, what you described, which is this carryover from a legacy system to some degree, right, or into another environment. So you get something out of it that is better.
Oh, we do it with the top level ontologies as well. So there is some kind of other drive.
So a key question is, if I'm talking about harmonization between ontologies, how big is the overlap? Am I looking at ontologies that try to show the same domain from different perspectives? Or am I looking at more or less complementary ontologies for different sub-aspects, modular parts of a particular domain? And then to some degree, the second task is going to be the easier one, because you basically need to work out what is the interface, how do you match up at the points of interconnection. Whereas if you have wholesale overlap, typically you expect different viewpoints have gone into the design, and organizationally, if not technically, you will have a hard time getting rid of that. So the harmonization will consist of establishing some sort of bridge, right? But you have to maintain that. So it adds to your structure. You're adding sound to the composition if you want, right? But the complementary aspect is one that could be easier.
So I'm not an ontologist, I'm more of a user. So I'm going to provide my perspective of what's needed or what's surprising. We integrate systems that are very complex. We don't have problems with that. We know how to make them interoperable, but it keeps being very surprising for me. We are incredibly unable to integrate the development information. If I do a test, even if it is super stupid, just measure the mass of a component, I am unable to integrate it directly with the overarching of the aggregate mass. I still need to take it manually and type it from one document to another, right? So there is an aspect certainly of integrating across domains that is important. And again, it's about the information that we generate during the development. But the second aspect or the second dimension is the maturity of the discipline, or maybe the domain itself. We have engineering domains that are mature, maybe mechanical engineering, where they are pretty precise about what they mean by certain things. And then we have systems engineering where you hardly find two people that will give you the same definition for what a requirement is. Okay, and that's another level of complexity, which is, well, and this is more, I guess, a question for the ontologist. To what extent does the discipline need to be mature so that you can create an ontology that people would play with? And the last question that I would put is, when we talk about harmonization, does it need to be top-down, or can we do translations between different ontologies? I just put it there.
Yeah, so I think we need ontology for harmonization, because we haven't been able to harmonize the term harmonization yet. Kind of unfortunate. Well, we usually talk about harmonization within the standards bodies. We usually talk about it going across multiple different standards and then figuring out how to, I guess, augment or how these standards can best work together. So we're thinking about it. It's not so much, finding sometimes not even this common terminology, but then trying to go down from a business case, such as what we're doing right now. Within MT-Connect and QI, Quality Information Framework, which is a metrology standard, measurement and verification, testing, and MT-Connect, which is a information from machine tools gathering data. We're we're working on harmonizing those two. So we look at it from top down, what are we trying to achieve? We bring these two standards together, what additional synergies are we going to get, and how best to not replicate the information across the two, but to augment one or the other with the other standards capabilities. So for things like in-process metrology, we're trying to collect data from machines about points that are taken and then verify them against a solid model geometry. We don't have a geometric model in MT-Connect, not necessary. We have one in QIF, which, you know, up to AP242 people, that's another issue, but we have these two, we have models, we have ways to be able to collect points. QIF has ways to be able to collect points. We call things slightly differently, but at the end of the day, we're measuring something that we're making, we're collecting data, collecting information about tolerances and verifying that everything is within spec. So if you look at it from the specification and the rules perspective, then we start to look at the harmonization processes. How do we start to use terminology, let's say that's defined within QIF, within MT-Connect, just enough to be able to get the two standards to work together to achieve that end goal. So we're looking at harmonization. We're not necessarily looking at like, how do we bring everything together? How do we make A look like B? But we're more looking at how do we use one within the other? How do we make an effective combined standard that gets us more than what we had in the beginning? We do the same type of thing with like ISA 95 and B12ML. Again, looking at, you know, this standard has this domain mapped out. Our standard has this other domain mapped out. How do we get the two domains to work better together by combining terminology at a higher level? That's where I think ontologies can help out, is because you can then do the higher level terminology. But I think if you try to go sort of bottom up on the standards, it's going to be a very painful process because there's just too much detail there. So.
Yeah, thanks for the different point of view. I mean, it's evident that the harmonization, a big benefit is in the complementarity of using the different. It doesn't matter if it's a standard, it is another different ontologies. I mean, the complementarity is the benefit. And that's probably will be the one that contribute to this cross-domain interaction, right? When we are talking about the ontologies and developing ontologies before harmonizing them, because if we need to harmonize them, is because we have different ontologies talking about similar or complementary things, but not exactly using the same language, right? And we have seen that ontologies experts have said that gathering as first step the requirements for what that ontology is intended to is a critical step for a good, let's say, ontology development. However, when we go for in the better place to find an ontology, we never found them. So maybe it's something that we have to think about. I mean, competency questions requirements are the first step, but we are not sharing them, so quite difficult to maybe to try to reuse this domain or whatever the ontology cover, right? If we do not really share that information, but maybe the first question should be, but how we should proceed for the harmonization of the things that we have in place, the main ontologies, upper ontologies, one to each other, before asking about the impact. But maybe now we can, unrelated to the Alejandro question, maybe you can comment on this point.
Okay, so I'm probably an outlier on this. So if you've got any data on anything, you have an ontology. So I find one of the things that the standard argument I have with people is I say you should start with data, and they say, oh, we don't have any data. This is a clean. And when you look, there's always something. So you have an ontology, so you just need a process to extract the ontology out of it. And it seems to me there was the comments that you guys made were useful. So you were talking about this looking for the overlap and where it doesn't overlap. And I think the issue is that if you think from a top ontology point of view, everything overlaps. So the issue is how
Is it working?
Yes.
All right, so where were we? I think the aspect with the top-down question is that at the top, you're going to have fewer entities that you have to contend with. So, well, looking at the current landscape, yes, as always, new ones are going to sprout, right? But it is a more overseeable space. So that is something where you can possibly deal more with an explicit acceptance of diversity to some degree. Whereas domain ontologies, where there's going to be a lot more, possibly more entities.
So I think the issue here is that I think a lot of people, when they take a top ontology and they put something underneath it, they feel as long as they can do some kind of link from where they are, they don't have to change any of their data, they just need to make a link and somehow they've done it. But if you take a top ontology seriously, it involves a lot of change. So I agree with you, there are fewer things, but the problem is they make such radical choices that I think it has. This is my experience. And so my experience would be you take the existing application system, you try and fit the top level on top, and you have to make quite a large number of radical changes to get it to fit. So it's high cost, and it's high cost in, not just in terms of the amount of time, but you need to have people who know what they're doing.
I agree with that, but you need that option.
Okay, that's true. Okay.
So yeah, I think, Chris, I agree with you. Everyone has an ontology, whether they've made it explicit or not, that's a different question, right? And to me, the very effort of making it explicit shows you a lot about the organization, the development processes, and so forth. Now, in terms of what do you do to achieve harmonization eventually, one statement that I don't agree entirely is you are driven by the use case. And the reason that I'm saying that is from general system development, we know if you just focus on that requirement, you lose flexibility, adaptability. And if you end up with, as you were saying, right, 1 million domain ontologies that are completely unscalable, non-modifiable, then you will never be able to achieve harmonization. So to me, one design rule is really about, well, I'm designing this for this use case, absolutely, but having in mind that someone may want to expand upon it, reuse it, and to me, given that harmonization covers so much stuff, it's not going to be the work of one committee or any one person, right? It's going to be the aggregation of work that lots of people do. So if we do not have in mind that someone else is going to eventually put one more stone into this pyramid, then I don't think it will ever happen. That's my guess.
So I have sort of a statement that I want to ask some of the more ontologically minded here. When you make decisions like choosing a TLO and top-level ontology, and you make those ontological commitments to it, I think you were getting at this, Chris, and Martin as well. How much does that limit your ability to then interoperate with other ontologies? Because from what I've found, sometimes those decisions that you make in the way you organize your ontology and the terminology and such, and when you start to inherit all the axiomization from the upper level, does that then mean that when you try to go to another, if you try to map to another TLO, or you try to even harmonize with another standard that's using another top-level ontology, are you then stuck? Are you in actually a worse position? Oh, one of you guys here, sorry.
So generally, I think it's more important that you have a TLO, and you have a TLO that's got these fundamental choices. That's the most important thing. And I think you get a degree of clarity, and I think there was a degree of generality. You were talking about this thing, if you've got 1,001 different things, you don't want to go there. And you can see the history of science is trying to find these general theories. We're doing, science is just an information gathering exercise, so we're in the same game. So you want to get these patterns that are repeatable. I think there are subtle issues though. So, and I think I've seen maybe Amelia will know, but I remember talking to Stefano about this work you did for Dolce to BFO, and I remember talking about how you did. There was something that appeared in, I think BFO is 4D, and there's some way of worked out some way of doing it in Dolce. I can't remember, but you 3D. Sorry, you get basically. I think there are trade-offs to be made in terms of the choices that you get. So, I was listening to something earlier about the maturity. I think we're such at an early stage of maturity that if you've got to worry about mapping between top ontologies, we should really pat ourselves at the back. We should go out for dinner. We should open the champagne. We've arrived. It's a really great place to be. So I think that. And I think it's really important at the early stages, if you look at innovation, not to close down ideas. So my worry is we don't have enough TLOs. We don't have enough examples of TLOs being used. I did a survey as part of work. I think it came out a couple of years ago, looking, I think, at 37 different choices. It'd be really nice to multiply that up, have 2 to the 37, I can't remember, whatever it is. Have 100 or 200 different TLOs so you can run against, because I believe that's the stage that we're at. So I know for a standards body, this sounds like hell on earth, but I don't think we're actually ready to stand. I think if you standardize now, it might be. I think you used the word, Marcus, preemptive, was it, or something? I think it really is a primitive. I'm not trying to stop some kind of standardization process to help people along, but not a standard that shuts everything, all the work down. I mean, we're at such an early stage. It's crazy to shut.
I'll only add one thing. I mean, that the interesting question is when we're saying, okay, harmonizing with another TLO, why am I doing it? What am I doing it to? Right? If I'm saying, if I have an isolated modular ontology, right? Okay. Probably I will not be able to avoid the detailed analysis that is necessary to make sure that I'm fitting with the axioms of the other TLO that I'm harmonizing with, and making sure that I'm not losing anything that is important to me. Right? If I'm doing this with a bunch of sub-ontologies at the same time, the question is, what are the conditions that make it worthwhile? So that's far more difficult, and you need basically a better business skills to do that. But the individual case where I say, oh, we have something here that is interesting, that may be something that is easier to achieve, but it may require more changes. But usually I expect that you will be willing to do those changes to get the outcome of lifting that over to the other side.
And you might learn interesting stuff for later. So I mean, there's all sorts of arguments for doing it. Non-standard, I think, if you're a standards body, you probably want to make sure that Marcus and I don't your committees. But, yeah.
I'll try not to. Yeah.
More work. But,
yeah, I mean, that's kind of the fear, is that you have so many different, it's almost like different languages or different modeling languages, you want to say, that give you your primary idiom, And which idioms did you choose, and how do you then promulgate that idiom throughout the rest of the group? So in other words, when you have a standards body and you have a whole bunch of people who really don't know about things like even modeling or ontologies, how do you get them to understand what's going on?
You see the same problem in science. So the issue is scale. So if it's only like
Yeah.
1%, sorry, 1% or 5% that are doing the experimentation, it's not an issue. I think the problem with the standard is when you roll it out to the 100%. So I think there's a lot of examples of how this innovation works successfully and unsuccessfully in the history and philosophy of science. So,
And there is one more aspect, which is standards become legacy so fast. And that doesn't happen with science as much, right? A little bit, but not as much. So to me, that's why, of course, there is a tendency in the moment you try something to make it a norm so that everyone follows. But when we're talking about an ontology, it's really this meta, super high-level architecture that is going to influence every decision you make. And standardizing it at the risk of legacy, because once you standardize it, it becomes legacy without passing the test of time. That's something I wouldn't support if I would be in that committee.
So there is one other point, which is I think is that the issue is reducing the cost of alignment and its ability to scale. So if you do manage to do this, then having 100 TLOs doesn't matter because you've reduced the cost. So I think the trick is reducing the cost of understanding what alignment means and developing processes that look at how you do something. So I was lucky when I started my work on ontology, it was in legacy modernization. So we were looking at the process of going from the old system to the new system. And we in fact spent most of our intellectual effort looking at the process rather than the actual TLOs. And I think one of the other TLOs, I mean, maybe I don't know Dolce that well, I suppose I was there when it was produced, but is that these other standards don't have, they look at the end product, and there's a really interesting article about medieval logic where they say that the process of formalization dictates more what the formalization looks like than the actual formal structure that you use. So I think the thing that's missing in all this is understanding the intricacies of alignment that you need to get right, and that's what. If I'm even asking what you should be working on to get right, and when you've done that, it's not a problem having, I don't know, the TLOs. If you can automatically translate between them, if you've got the infrastructure, the tools to do the alignment, then the problem disappears. And you need to work out how to align because you've got an enormous amount of data. I mean, unbelievable amount of data that you want to ontologize. So if you can get this process for extracting ontologies and aligning between them, then it's then the problem. I think you have a different picture of the problem. I understand why I don't know why there's angst about the problem now, but I think if you step back far enough, I think it's not. You can. This is why I actually have. I wasn't going to say it, but I think that this process of looking at requirements is a mistake. You need to try and do something to work out what the requirement. We need to discover the requirements. If you think we're going in, you know what the requirements are with most of this stuff. If you're at the early innovation stage, in the literature it says it's a mistake and they're right. So.
You mean by requirements? You're talking about, but you should know your top level business case. What you're trying to achieve, correct? Not necessarily.
I personally, I like taking a hardcore case, basically to start the argument going. So, but I think I would win. We would, I would have to move a little bit towards you. I agree. But I think if you're looking at an application system that you want to work on, and you say, okay, now I need to replace it. If you then try, and you can work out some of the things that it does, but as soon as you articulate the requirements, you're placing constraints on the answers that you can get to. And that's one of the things I think when you're doing innovation, you don't want to do. So if you know this market diffusion curve where you have innovators, there's a lot of the discussion about ontologies at the moment is late majority. It assumes that everything's there, we've got millions of standards. It's not innovation talk. And I think we're at a very, very early stage, at least for the kind of ontologies that I'm in. I mean, there are lots of different flavors of ontologies and stuff, but I think that's where we are. So
I think my issue is your definition of the term requirements.
I'm happy to get.
So that's because I usually think about, when I look at a problem, I usually try to look at it from sort of a business case downward and say, okay, what are we trying to achieve? And then come with things like competency questions, and then how are we going to answer, at least provide value to somebody with the work that we're doing?
For me, that's theatre for management. I think that's not the issue. I think there is And I'm in a lucky position. So what I would tend to do, or a project that I go for, it's something that they've got to do anyway. They made a business case for shifting from Maximo to SAP or something. And I say, let's do it this way. I can do it cheaper, and I'm going to do it differently. And they just hear cheaper, yeah, and they go for it. And I think the thing is, each time I find it's done, there are things that emerge that are different. And what I'm trying to do is create the space to do the different things. And even the terms, what happens is that we sometimes do the requirements for fun,
Yeah.
and then we go back and look at them. And our pictures change so much, halfway through, quarter way through, 3/4 of the way through. But if we look back, if we'd taken the requirements too seriously and tried to follow them religiously, we wouldn't have gone down these interesting paths.
I think what you're talking about is a pretty bounded project that has existing information models. If you're trying to like greenfield a new area, or like you're trying to develop a standard around new terminology, or trying to even harmonize other other models and create something sort of synergistic.
Can I remind you of what I said 5 minutes ago?
Yes, very good.
Okay, I said, so what we do is we say you look for data. Well, people say there's no data. It's a greenfield site. There's no data. And I understand what you said. Everyone says it. But if you look carefully, I'm willing, you give me a case, I will show you the data.
No, there is data. I'm just saying that you're trying to build new models. It's not like what you're talking about is more going from two systems that have predefined models.
You understand.
I'm trying to create, in standards development, I'm usually trying to create new models, or when I'm harmonizing, I'm trying to say, okay, I have these two existing models, how do I bridge between?
Well, we've done work on it.
Yeah.
The reason we go for it is getting ontology from unstructured data is really costly and low quality. So you really want to go for structure, which is the reason I use those examples. So if I was given the job of trying to develop ontologies and I was given 6 projects to choose from, I would choose the ones when I went from structured data to structured data. There have been cases where we've been told you've got to do this other stuff, and we do the other stuff. And there's always a way of finding some kind of data to allow you to start and do the testing, some way to anchor you to what's going on, and even for things that are completely unstructured. Yeah. Try. Yeah. I think I know earlier. I said 14.224, and it's a mess inside. I mean, it's an unbelievable mess. There were 2 or 3 tables that when we took apart, it took weeks and weeks to try and work out. We're talking to experts trying to work out what was in there, but it was somewhere to start rather than starting from scratch.
Yeah, I mean, you're very rarely starting from scratch. Often you're trying to either define or collect from domain experts their terminology and then create something. So I think it just seems like a different workflow.
Okay, so I'm giving a talk later, and I think I'm arguing that for ontologies to work, we need different practices, and it's really I should have you up there with me, because
we could argue.
No, but you can articulate the old practices, yes. And I'm saying that look, if this is going to work, I'm not disputing that most projects people use those practices, because that's what most people know, that's what most people do. But if you try to get ontologies, you need new practices, I think, which it shouldn't be a surprise, really. If it's something innovative, yeah.
But I think, Chris, that's the case with every innovation. The difference is when you are talking process innovation, they don't follow the same circle as technology innovation, because you cannot test it in a lab. Okay. Companies can adopt it really quickly. You do not see the effects because there's so many variables that are confounded.
So you're talking about manual process, not an automated process.
No, to me it doesn't matter. What I'm saying is when you are doing innovation on processes, it is a tendency for organizations to not realize that they should follow the same cycle as you're talking about innovation in technology. Yeah. Because with technology, it's really easy to say, I'm putting in the computer doesn't work, right? Yeah. Whereas here, processes, adoption in a company, changes of practices, technology embedded within the process, new practices, culture. And this is why companies are so tempted when you say cheaper, they just go take it, right? Yes. And maybe you say, oh wait, this is not what I had in mind. But I agree with you, right? When the process is not mature enough, the cycle of working should be this innovation. It shouldn't be traditional development, mature requirements you follow, or recycling. It should be different. It's just I've not seen it with processes because it's usually adopted as, oh, this is mature. You talk MBSE, you talk agile development, right? Six Sigma. It doesn't really matter. Companies just jump to it without checking, is this mature? Does it really fit my culture? That's what I mean. It's a common situation with a very well documented set of consequences for most organizations, which is they do not capitalize the full potential that it has.
And I think the issue goes back down to the first question, was what's the economic benefit? And I think that certainly when I see it is that you get these amazing compressions in the amount of really code a lot. So you get the reductions in code of orders of magnitude, you get increased functionality, you get this problem about someone was talking about focusing on a use case. I can explain why, but what you do is you get things that are more general, that span multiple use cases. I mean, if you look at, there's an example in history of philosophy of science, they talk about one of the signs of a good theory is fruitfulness. So it solves results that you never anticipated. Right. So what you should be looking for is the same thing in your development processes, which if you talk to an IT person, they'll say you're crazy.
Because you're talking innovation, right? Yeah, if I'm talking about development, it's like, this is the problem I have today, just fix it.
Yeah, exactly.
Those are architectural approaches. And when you're going through an architectural approach, you try to ask those questions, you try to create that innovation, a broader use of.
I think there are those cases, but I think this arises. I'll be talking about it later. This arises about looking at the data. I mean, in fact, Emilio's talk, we had these three definitions. Is a kind of, it's not quite the same, but he's saying, look carefully. They're different things here. Just look carefully. And I think that's in what I do, in the ontology that I do. That's the game. It's looking really carefully at the detail to try and see the small changes that make a difference.
But you can still do that in the context of a use case, as long as the questions you're answering are ones that are difficult to answer without an ontology.
I think, Eliza, I knew we would get across swords. In my experience, I have actually no experience of that working, and I have lots of experience with failing.
Then we just had differences of experience.
Okay.
Yeah. I think you can do it, but I think in general, it's difficult within the pressure of organization and the limited resources.
Then I welcome your feedback after Heiner's talk.
Again, I'm sure there are cases, but.
Okay, so I'm so sorry, but I have here to stop the discussion. I will have now a short very coffee break because we have run out of time, and there is a keynote to speak right now in 10 minutes. So thank you so much for this interesting discussion. Sorry because I have not had the chance because of time to provide you the work, but you can find them in the coffee breaks and during this day. So thank you so much.
So the keynote
It's fun.